Yes, welcome to this other session where we shall be going through network devices in computer networks. So basically, network devices, they are hardware components or software applications that we use to facilitate communication and data transfer on a computer network. Now, of course, they play a very crucial role in establishing and maintaining network connections. These devices allow for such connections to take place, such communication take place. They manage traffic, determine how data should move, and it should go where, and ensuring data reaches its intended destination securely and efficiently. For example, we have what we call the repeater, we have the hub, we have a bridge, switch, routers, gateway, and so on and so forth. These are all examples of network devices. Another word we use to refer to network devices is what we call the nodes. So when you hear nodes, just know we're talking about the different network devices. Types or classification of network devices, we have those which are end devices. Now these ones basically are the originators and also the end result, I mean the final destination of data flow on network. They can either be hosts, such as maybe a computer, a server, a printer, or they can just be clients, those that are receiving them from whichever side they're receiving from. So usually these end devices have a unique address that identifies them on the network, which we call the IP address. So these are the end devices. They originate and also they terminate data flow on the network. On the other hand, intermediate devices, they connect end devices and allow data transmission on a network. So you can find that between 2 or 3 end devices, you'll have an intermediary device, which will act as the middleman between the 2 or 3. So intermediate devices can be hubs, switches, routers, repeaters, firewalls, and so on. They perform functions such as filtering, forwarding, amplifying, translating data packets to wherever they are being sent. Now, the major objective of network devices is that they facilitate communication and collaboration between nodes within the network. They enhance network performance, security, reliability, and so on. They expand network's coverage by amplifying or originating signals. Here you can think of a repeater, which is able to do this kind of work. Dividing or filtering traffic, talk about a router. They can be able to do that. Interconnecting different types of networks by converting or translating protocols. This is possible because of these network devices. They also direct packets to their intended destinations by determining the optimal path. Here you can talk about a router, you can talk about the switch can be able to do that. Safeguarding network against access, talk about a firewall here. Enable wireless connectivity, talk about the wireless access point. It can be able to do all that. So all these network devices have a major work they do as far as networking is concerned. We shall look at the first one, which is a switch. A switch basically functions at the data link layer of the OSI model. We have the OSI, which is basically a reference model as far as networking is concerned. Then we have what we call the TCP/IP model, which is applicable as far as network communication is concerned. So the main purpose of switches is to connect end devices within a network. They connect end devices within a network and allow the forwarding of data packets utilizing their MAC addresses. The switches are able to capture the MAC addresses of each individual device. This is specific. Each individual device has a specific MAC address which is used to identify it. So the switches are able to do that. Now, switches are multi-port devices which, by creating collision domains for each port, can effectively mitigate collisions and congestion in the network. Switches are capable of configuring VLANs to establish logical groups of devices on network. So the switches look like this. They just look like this. They have multiple ports. They're available. We can use them layer 2 switches in the data link layer. But also, if you're going to use a layer 3 switch, it can be able to work also in the network layer. It almost has the same capabilities as a router has. So a layer 3 switch can be able to work as far as packet tracer is concerned. So let's go to the next device. Let's go to the types of switches. We have what we call the unmanaged switches. These switches do not offer advanced configuration options. They are basically plug and play. They're suitable for small networks or for use as an expansion to a larger network. They are simple to manage. Then we have what we call the managed switches. These switches offer advanced configuration options such as VLANs, QoS, link aggregation. They are suitable for larger, more complex networks and allow for centralized management. Now these ones, at least you can configure them to do what you desire it to do. The smart switches, these switches have features similar to the managed switches, but are typically easier to set up and manage. They're suitable for small to medium-sized networks. This is quite obvious. So these switches can also be classified into two. We have what we call the layer 2 switches, not what we call the layer 3 switches. Layer 2 switches operate at the data link layer, like just I told you earlier on, and they're responsible for forwarding data between devices on the same network. If you have a simple local area network and you have a local area network, meaning they're in the same network, you have your 2 devices or 3 devices, you have a layer 2 switch in the middle there, which will help to forward data packets between those devices in the same network. However, layer 3 switches, they operate at the network layer of the OSI module, and you can route data between different network segments, which means it more or less does the work that routers also do. So a multi-layer switch operates at both layers, meaning it can operate as a switch and also as a router. A multi-layer switch supports the same routing protocols as routers. That's the amazing thing about it. Okay, we have another device which we're calling a switch here. A switch basically operates at the data link layer of the OSI model. Their primary role is to connect segments within a network and enable the forwarding of data packets based on their corresponding MAC addresses. This is quite similar to what switches do. It also forwards packets based on their MAC addresses. So bridges are equipped with filtering capability to discard unwanted packets or forwarding to pass desired packets. So a switch, a bridge basically looks like this. It's quite similar to what a switch looks like. The only difference is that it doesn't have so many ports as it is with the switch. So this is what a bridge basically looks like. Then we have a router. Routers operate at the network layer of the OSI module. Their main job is to direct traffic or connect networks and allow forwarding of data packets based on their respective IP addresses. The switch based on the MAC, the bridge based on the MAC address, but for the router based on the IP addresses. Routers establish communication by maintaining tables about destinations and local connections. Apart from that, routers use different routing protocols such as RIP, OSPF, BGP to determine path for transmission through routing processes. So common types of routers, you have the edge routers, access routers, and so on and so forth. This is what it looks like. You have your access ports where you can put your Ethernet cables to connect to other devices within your network, and then you can have you have these antennas which probably supply Wi-Fi depending on what you want to use it. Then you have what you call a firewall. A firewall is an intermediary device also. It operates at various layers of the OSI model depending on its type. It can be either hardware or software, and its main purpose is to protect the network from any unauthorized access or malicious attacks by enforcing policies or rules. It controls what goes in and what goes out. They analyze and restrict data packets based on programmed parameters. So this is what a firewall does. Like we said, it can either be a software or it can also be hardware. So think of one like this. This is a hardware firewall, but there are many types you can think of, and so it's basically to protect our network from unauthorized access. Then you have what we call the repeaters. They're sometimes also known as signal boosters. The main function is to regenerate an incoming signal, amplify a received signal from the sender before retransmitting it to the receiver. As a result, the signal covers longer distances, sometimes more than 100 meters. For standard LAN cables, it operates in the physical layer of the OSI model. So that's basically what a repeater does. It's responsible for converting data between different network signals, such as optical, wireless, or radio signals, and so it sends them to whoever has a device to receive it. This is what a repeater looks like. You can get another which may not resemble that, but this is the basic one that I can show you. Then we have a hub. A hub is quite similar to the bridge, but these devices usually operate in the physical layer of the OSI model, and they connect multiple devices on this local network. They connect multiple devices, more or less what a switch does. Hubs function by broadcasting data to all devices that are connected to it, regardless of their destination. And this is a major challenge with the hubs. So you prefer to buy a switch in comparison to using a hub, which basically sends packets to all devices connected to it. A hub also acts as a repeater, amplifying signals that deteriorate after traveling long distances over connecting cables. Then we have a gateway, also quite similar. They are intermediary devices that usually operate at the network layer of the OSI model. They are responsible for connecting networks that are using different protocols or architectures. They do so by translating or converting data formats or protocols between different networks. So this is quite amazing. That's what a gateway looks like. You have a modem. These are quite old. The network devices that usually operate at the physical layer of the OSI model. They can modulate or demodulate or convert analog signals into digital signals. That's basically the major work they do. So you have a simple diagram here which can show you that. Okay. Then we have finally what we call the access points or the wireless access points. The network devices that usually operate at the data link layer of the OSI model and are mainly used to bridge the wired and the wireless network. They act as a bridge between the wired and wireless network. So you find that in simple terms, it's a device that allows wireless capable devices to connect to a wired network. A wired network brings the signals to that device, and the device is able to broadcast it to whoever is able to receive it. So it allows access to more wireless clients and expand the wireless network range. It is very suitable for large offices, used in offices or public places that need to provide wireless access to many users or devices. I think this is what it looks like. This is what it looks like. It wants to resemble a router, but this is basically a wireless access point. Then finally, we have what we call a NIC, which is Network Interface Card. Operates at the data link layer. It's a hardware component that is responsible for enabling a device to connect to the network. So most of our desktop computers have this inside them. The same applies to our laptops. They have a network interface card inside there, which is able to allow them to connect to internet. This is what it looks like for a desktop one. And also on your laptop, you see where that Ethernet port is. You know that system has that network interface card in it. So I think we can call it off for now. Till then, thank you for watching. That is all we have for network devices. There are many others you can make research about, but for now, these are the basics that we can talk about. Till then, stay tuned.